If you're given this triangle and they ask you, what is the angle C, would you be able to solve? To solve this question, we're going to need the cosine law. So if we draw this triangle here, the cosine law relates the lengths of the sides of the triangle to the cosine of one of its angles through this equation here, where the lowercase a, b, and c are the side lengths, and the capitals, in this case it's capital C, are the angles opposite to the side lengths. So for us, the capital C is opposite to the C side length, as you can see in the triangle. If we use cos 90, we get back the Pythagorean theorem. So if we plug in 90 into the cosine law, we get just C squared equals A squared plus B squared. That's why cosine law is referred to as the generalized Pythagorean theorem. If we go back to our example problem here, and then we use our cosine law equation, we can label the side length 6 meters as lowercase c. We can label 5 meters as lowercase a, 4 meters as lowercase b. Plug these values in to get this expression here. And we're isolating for capital C, our angle. If we do that, we can bring 5 meters and 4 meters to the other side, and then we can evaluate these squares. And then we can add the terms on the left, and we can compute the term on the right, and we get this expression here. And then we can multiply through by 1 over 40 meters squared to isolate for C. We can take the inverse of cosine, and we get this here, which corresponds to our final answer here, which is approximately 83 degrees. So this is the angle associated with the capital C on the triangle. That's what we solved for. You can see that below. I just want to note that the cosine law is useful for whenever you're given a triangle where you know all 3 side lengths or 2 side lengths and their associated angles. And then another note, you can also write the cosine law in terms of a different side length and angle. So in the second line, it's small a and big A, and then in the third line, it's small b and big B.